Hello guys, welcome back to my YouTube channel. So today's daily LeetCode question is find if the path exists in the graph. So we are given a bidirectional graph with n vertices. So we need to decide that our source and destination are able to reach using that graph or not. So the labeled will be 0 to n minus 1. The node labels will be. So we are given edges of the graph where this will be the start node and this will be the end node, the connecting node. So edges is a two-dimensional array which contains multiple edges. So we are given edges, n number of nodes, source and destination. So we need to return the true if the path exists in the graph, or else we need to result the false. So let's look into an example to understand this problem clearly. Look into this example. So we can clearly see that the number of nodes are 3 and the edges are 0 to 1. If it is given that 0 to 1, it means that it is bidirectional. So 0 to 1 and 1 to 0 both are possible. There are no two routes given. Okay guys, now it's another edge is 1 to 2. So this is the edge number 1 and this is the edge number 2 and this is the edge number 3. So our source node is 0 and our destination node is 2. So we can clearly see that we have two paths. The first path is this and the second one is the direct path from 0 to 2. So we can consider any of the path and we can simply return the true to the function. Okay guys, now let's look into another example to understand this problem, and we have to keep in mind the negative. Okay guys, this is example number 2. So we are given 6 nodes, means 0 to 5. So our edges are, this is our first edge 0 to 1 and our second edge is 0 to 2 and our third edge is 3 to 5 and our fourth edge is 5 to 4 and our fifth edge is 4 to 3. So we can, in graph traverser, if we are n nodes, then edges will be simply n minus 1. So we have 5 edges and 6 nodes. So our source node is 0, so this will be our source node, and destination is 5. So we can clearly see that there is no path exist in this format, so we have to return the false. So how we will find out that is there any path exists or not? So we have to use two methods. So the first one is DFS and next one is BFS. And probably the third approach for finding the paths will be the union find. So I want to discuss any of the two approaches because we can solve this problem using 3 approaches. So I will discuss DFS and union find. So this will be probably a good question to answer. Okay guys, now let's discuss the approach 1. So my approach 1 is, if we will just follow the DFS method. So if we follow the DFS method, so we need to find out the node and its adjacent nodes. So if we consider 0th node, the adjacent node will be 1 and 2. If our node is 1, the adjacent node will be 0 and 2. If our node is 2, the adjacent nodes will be 0 and 1. So how can we form this institution? By using the given edges. So we can use a hash map and we can just tabulate this into the, see, if given is 0 and 1 as the edge, so we can hash map we can point 0 to 1 and 1 to 0. So for the 0th node we can add 1 into the array. For the 1 node we can add 0 into the array. So this is how we form the institution of the DFS. So now let's look into the approach. So we are at the starting node of the source node and we will find out what are its adjacent elements, and we will look into that if the adjacent elements are reaching the destination or not first. So the 0th element neighbor elements are 1 and 2. So we will first traverse to 1 and we will check the nodes of the adjacent one. So we will be maintaining a visited array. So this visited array is maintained, so sorry, this is a set. So we will maintain a set of visited to just to avoid the cycles. If the node is not connected, so we have to avoid the cycles, right? So if we once visited the 0th node, so we can't visit the 0th node again, so we will be moving keeping forward only. So we will move forward only. So first we visited the 0th node, then we will visit its neighbors node. So what is the 0th neighbor? 1. So we will visit the 1. Now if we going to 1, then again we will encounter the 0. We have already visited the 0, so we just need to avoid this node. We will simply move to the 2. Okay guys, now let's look into the optimized approach. So the optimized approach is, so hence there are 3 nodes, so we can simply maintain a boolean array of 3 nodes, size of 3. So it is numbered from 0 to n minus 1, then there is no problem. So we can simply change the true and false values. So here what institution we can form is, so this is our source node and this is our destination node, right? So initially the boolean all values will be false, so we will just first change the source nodes to the true, hence the error will look like somehow this. So it will be true, false and false. So we will be checking that the first edge of our 2-dimensional array is 0 and 1, then next edge is 1 to 2, and the next edge is 2 to 0. So here we can clearly observe that is 0th value and 1th value are equal? No. So the first index value is false and next 0th index value is 0. So we will make the both into the true. Okay guys, so we will simply make it true, true and false. Then here another institution is, and at the end we will be checking that is our destination found. So we will be just keep on checking that the boolean array of destination equal to true, then we can simply say that we have reached our destination. There is path exists from our source node to the destination node, so we will return true. Otherwise at the end of the loop we will just return the false. Okay guys, now this is the optimized approach, and this has the space complexity of big O of n and time complexity of big O of n. Okay guys, now let's look into the code explanation. Okay guys, now let's look into the code explanation. So as I earlier said that we will be looking into the DFS approach. So here we will be using a hash map and we will be just framing the connections to the each and every node from 0 to 1 and 1 to 0. Okay guys, so this will be the edge 1 and this is the edge 2. So we will be maintaining a visited set and we will be following the DFS approach. Now in the DFS approach we will be passing source node, destination node, our graph and visited set. So to stop the cycle infinity loop, infinity recursion, we will be using if the node equal to destination. So if our destination is arrived, so if the path exists, so we will simply return true, or else we will just add that node into the visited array and we will be checking that our node exists in the graph and it has any neighbors or not. If yes, then please traverse that neighbors first and check if our destination path exists. Okay guys, now if the neighbor is not in the visited, then only we can perform DFS to it, because we have to avoid the cyclic formation. So we will be maintaining a visited array. If once the node is visited once, so it can't be visited twice. So we will be maintaining this condition